today's video, we are going to see some questions, some tricky questions from Digital Electronics Multiplexer session. That is, we are going to do some questions from MUX or Multiplexers section. These type of question, if you see this board, you can see a figure connecting two multiplexers. Sometimes these type of figures you will be facing in examinations, that is in competitive examinations or in your semester examinations. Sometimes that can be confusing. So we are going to see some tricky questions from the MUX area. Okay, so here this question is to find the output function X. Okay, so this circuit is consisting of two multiplexers. Both are 4:1 multiplexers, both consisting of 4 inputs and 1 output. And there are select lines. Here also there is select lines. You need to find what is the output function X. So before going into this output function X of the second multiplexer, we'll see what is the output of this first multiplexer, which is Y. Okay, actually I have done this question in one of the previous year question discussion video, but I thought of doing it as a separate video because a lot of people find it very difficult to solve these type of tricky questions. Okay, so let us see how to solve this question. So first we are going to write the output expression for Y equal to, you can see very clearly that only for two inputs the values given are 1. For the other two inputs the value is 0. So the value is 1 for only I1 and I2. I1 means 0, 1 and I2 means 1, 0. So the output is 1 or Y is 1 for this combinations of select lines 0, 1 and 1, 0. Or you can write it as A bar B plus A B bar. This is nothing but XOR, right? A XOR B. So your Y expression is A XOR B. Okay. So this output, which is A XOR B, is getting passed on to the select line of your second MUX. Right. So we'll for a moment ignore the fact that this Y is A XOR B. We'll just consider this as Y only. Okay. So the select lines are Y and C. Here also you can see for only I1 and I2 your inputs are 1. For rest of the inputs the values given is 0. So your output X, that is the output of your second MUX, will be 1 4 1 0 combination plus 0 1 combination only, or for 0 1 combination plus 1 0 combination of your select lines only, right? Or you can write it as Y bar C plus Y C bar. This again is equal to Y XOR C, right? So your output expression for your second MUX, or which is your required expression for X, is actually equal to Y XOR C. But we know that Y is A XOR B. From this expression, it is A XOR B. So we'll put it as A XOR B. So the final expression X is equal to A XOR B XOR C. Or if you specifically write it in terms of the variables A, B and C, not as an XOR expression, you can expand this A XOR B XOR C. And the given expression is like this. I'll write it. X equal to A bar B bar C plus A bar B C bar plus A B bar C bar. Remove this. A B bar C bar plus A B C. So this is your final output expression for X. Okay, so that is your final output. So how to solve this question? First we need to find what is the output expression for your first multiplexer. First multiplexer is having outputs for only I1 and I2. I1 means 0 1 and I2 means 1 0. For A bar B combination and A B bar combination only your inputs are 1. For rest of the cases inputs is 0. So your Y is equal to A bar B plus A B bar, which is A XOR B. Now this is getting passed to the second multiplexer select line. There again you are getting Y XOR C. Now you have to substitute Y as A XOR B. So A XOR B XOR C. Just expand A XOR B XOR C, you'll be getting this expression, which is A bar B bar C plus A bar B C bar plus A B bar C bar plus ABC. Okay, so that is your expression for your X. Okay. The next question is, find the logic expression or logic function implemented using this 4:1 multiplexer. So these type of logic function implementation using MUX, these type of question is very common in competitive examinations especially. So you have to, that is, you can use MUX for implementing various functions. Just like logic functions and, or, nor, XOR. Likewise, these functions can be implemented with the help of multiplexers, and here a 4:1 multiplexer is used to implement some logic functions. What is that function? You need to find. Okay, so we'll start from this end. You can see here this triangle is indicating a ground. Okay, so that is a, when considering on digital electronics basis, that is a 0. Okay, so this is a 0, and here it will be 0 complement, it is 1. Again, 1 complement is 0. Right. So what are the inputs coming to I0, I1, I2 and I3? We'll write first. Okay. So I0 is 0, I1 is 1, I2 is 1, I3 is directly connected from the ground with before complementing. So it is again 0. So that is a 0, 1, 1, 0. So from this itself, we can write what is the expression. Without even proceeding further, we can write the answer for this question, because in the previous question, just before we have solved, we had this combination and the function was what? The function was XOR, right? That is a P XOR C is the, sorry, P XOR Q here. It is Q. P XOR Q is the logic function implemented F. But anyway, just like in the previous question, that's why I'm saying the function is P XOR Q. But anyway, we'll see. Okay, so we'll write P, Q and F. We'll see for various combinations 0, 0, 0, 1, 1, 0 and 1, 1. We'll see what is the output coming. For 0, 0 combination, which line is getting selected? It is I0, and 0 is the input for I0. Then for I1, 0, 1, it is 1. For I2, 1, 0, I2 is 1. I3 is 1, 1, it is 0. So here it is A bar, sorry, it is P and Q. So it is P bar Q plus P Q bar. That is nothing but P XOR Q. Okay. So the function is F equal to XOR of P and Q, or it is P XOR Q is the logic function implemented. Okay. So I really hope you understood how to solve these type of logic function type of questions. That is, you have to write the truth table for this multiplexer, and you have to see what truth table is that corresponding to. It can be sometimes for OR gate, it can be sometimes for AND gate, it can be sometimes for XOR gate, just like this question. So from the truth table, first you have to write the truth table of this MUX or whatever circuit MUX combination, whatever is given to you, you have to write the truth table with these inputs and the output coming. Okay. And then you will be getting some combination which will be corresponding to some of your logic gates. Okay. Then you have to find. Here it is XOR gate. The next question is a little bit twisted question. You need to find the output function, but it is in terms of the min terms. That is, you have to implement the K-map of this function. First find the expression for this F, which is a logic function. Then solve it using K-map simplification, or find the min terms from the K-maps. Okay, so that is a question. So it is a little bit twisted question, but once you get the concept of this type of questions, later on it is very easy for you to solve. Okay, so this is again a 4:1 multiplexers. Most commonly you will be only seeing 4:1 multiplexers, and there are two other gates also connected to the input side. There is one NOT gate and also a AND gate with two of its input inputs complementing at the input side. Okay. Now what is the expression? I'll write first the logical expression. Here I'll start writing from here. F equal to, or f of a, b, c, d. What is the function f of a, b, c, d? When a and b, we'll write the truth table. Okay. A, b and f. Then when a and b are 0, your I0 is getting selected and it is C. Then when 0, 1, then it is D. Directly D is connected. Okay. Then it is D. Then for 1, 0, C is getting complemented. So it is C bar. Then for 1, 1, it is C bar, D bar. Don't confuse it with CD bar. It is C bar into D bar. Initially C is complemented and given to AND gate. Then D is complemented and then given to AND gate. So it is C bar, D bar. So this is the truth table for this 4:1 multiplexer. Now if you write it in terms of an expression for ABCD, that is f of ABCD, you will be getting A bar, B bar, C plus A bar, B, D plus A, B bar, C bar plus A, B, C bar, D bar. Now, this is your expression. But in order to solve a K-map, you require all the variables in all expressions. Okay, you actually not require, but we'll try applying all variables to these 4 terms. So, in order to introduce a D here, we can just add a D plus D complement to this term. Here we'll add a C plus C complement. Here we'll add a D plus D complement. Okay, so we'll try doing that and we'll see what is the expression coming. So it is A complement, B complement, C is there, then we'll add a D plus D complement. So even if you add this D plus D complement, that is 1 only, so no major change. But just to have a K-map expression properly, we'll add a D plus D complement, right? Then here A complement B, there is no C term, so we'll put C plus C complement into D plus A, B complement, C complement. Here also we'll put a D plus D complement. Okay, then the last term, this is the last term which has all the variables. So we'll put as it is A, B, C bar, D bar. Okay. So now we'll try implementing this into a 4 variable K-map. So this is your expression. Actually this was our expression, but we have just introduced D plus D complement and C plus C complement, these type of terms, to have all variables in all terms. Okay, now I am going to implement as a 4 variable K-map. Okay, here. I hope you can see it very clearly. Okay. So my K-map has 4 variables A, B, C, D. Then 1, 2, 3, 4. 1, 2, 3, 4. 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. Just to remind you that we have done I think 2 or 3 videos on K-map. 5 variable K-map also we have discussed. Okay, so please to watch that videos, that is in the digital electronics playlist. A lot of people find it very difficult to solve K-maps, but I have tried to simplify that concept in those videos. Okay, please try to see it. Now we'll write these expressions as min terms. Min terms means writing as ones. Okay, or write ones in the K-map are min terms, zeros are max terms. Okay, all these things, the basics I have explained in those videos. So first term we'll try to put in the K-map, A bar, B bar, C, then D plus D bar. So where is A bar, B bar, C? This is A bar, C bar. Then where is C? C is here. Yeah. So here. So the ones are here and here because D plus D bar, both this we are taking. That is, we are taking A bar, B bar, CD and A bar, B bar, CD bar. So we have to put one here and here. Right. Next term is A bar, B and D. So it is A bar, B and D is here. So we have to put one here and one here. Okay. Next term. So we have realized this. We have put one on this. Now we need this term. That is A bar, B bar, C bar. Okay. So A bar, B bar. It is not A bar, B bar. It is A, B bar. Okay. That is here. A, B bar. Then we need a C bar. So it is here. And we need ones for D and D bar also. So we'll put one and one here. Okay. Try to expand this bracket and you will find the exact expression for this one and all. Okay. Next, last term is this one. So we have realized this one also. Then this one is A, B. So it is here. C bar, D bar. C bar is here. Yeah, it is here. A, B, C bar, D bar. Right. So these are all our min terms. Now we don't need min terms. We need the positions, right? In which all, if you see the options, you can see the position of min terms are being asked. The function is realized and in which all positions on the K-map the min terms are present. That is a question. So we'll put the position values for all these columns. So it is 0 here, 1, 3, 2, 4, 5, 7, 6, then 8, 9, 11, 10, 12, 13, 15 and 14. So where all the min terms are present, I'll use a different color. Okay. So the min terms are present at 2, 3, 5, 7, then 8, 9 and at 12. So these are the position values for your min terms. Okay. So your expression will be F equal to sigma 2, 3, 5, 7, 8, 9 and 12. Okay. So this is your expression. Now you can see it. Which is your expression? Actually, I forgot to put ABC here. A, B, C. Only 3 options I have included. So the correct answer is C. Yeah. So the correct answer or the correct expression in terms of min terms is sigma M. Sigma M indicates min terms. Okay. 2, 3, 5, 7, 8, 9 and 12. The correct answer is option C. I hope you understood how to solve this question. Okay. First we need to write the truth table. Then we need to write the logical expression. Then try simplifying it using a K-map. Either you can use this expression. If you can use or if you can simplify using this expression only, you can try. Or you can make it more easy by putting a D plus D bar to this expression and try to introduce all variables in all terms. Okay. Then it is very easy and very clarified expression you will be getting. Then you try to realize using this K-map, which is a 4-variable K-map, and try to find where all the min terms are present and write the expression. Okay. So it is not just sigma, it is sigma M. Okay. So the correct answer is option C. Also, see, if you are taking only this expression A bar, B bar, C, means you have to take the columns where A bar and C bar is present. That is in this row. Column means this one. Okay. So this A bar and B bar is in this row, and C means you have to take this also and this also. So you have to take ones in these 2 columns. Okay. So either you can, as I said earlier, either you can use this expression, but if you put like this, it is very easy to understand. So that's why just put a d plus d bar. So you can understand that the values are present in d column also, d bar column also, where c is 1 and also a bar and b bar. So that is these two ones. Okay, so this is more clarified version. You can also use this expression. Try solving with that also. Just tell me in the comment section whether you are getting the same expression or not. The next question is this. You need to find the expression for Z, and we'll see this question which is having again a 4:1 multiplexer, and there are two gates connected at the input side, and the select lines are R and S. Okay, we'll first start writing the truth table. So for R, S, then we'll find what is Z. 0, 0, 0, 1, 1, 0, 1, 1. And for 0, 0, what is? Yeah, don't get confused here. It is from I0, I1, I2 to I3. So from here it will start 0, 0 likewise. Okay, sometimes these can come as twisted to confuse you, or in order to make you, that is, you may sometimes make it wrong. Okay, so to confuse you, these type of changes they will introduce in the question. That's my idea. Okay, so for 0, 0, it is I0, not I3. Don't confuse. Okay, it is I0. That's why it is given as I0, I1, I2 and I3. Okay, so 0, 0 means I0 is coming, and the expression is P plus Q bar. Okay, P plus Q bar it is. It is also not Q, it is Q bar. Then for 0, 1, your I1, that is P. Then for 1, 0, it is PQ, I2. Then for 1, 1, it is again I3, which is P. So this is your truth table. Now from this truth table, next step is to write the expression. Okay. Then the third step is simplification by either using K-map, or you can simplify by using some other simplification methods. Okay. Next step is to write the expression for this. So what is the first expression? R bar S bar into P plus Q bar. Okay, I'll write it here. R bar S bar into P plus Q bar. Then next one, so we have written this, then plus R bar S P, that is a second expression or second term. Third one, write it below, R S bar PQ. Then the last one is R S P. So these are the four terms corresponding to these four combinations. First one, second one, third one and fourth one. So R bar S bar into P plus Q bar, R bar S into P, R S bar PQ, R S P. Now you can expand this bracket. Okay, I'll expand it. I'm going to remove this truth table. Okay. So once you practice these questions, it's very easy. See, digital electronics is just a matter of practice. Unlike other subjects, sometimes the questions in other subjects, sometimes for example in network, sometimes it is very difficult for you to even understand. But in digital electronics, what is the advantage is that once you practice a sort of question or an area of question, it is very easy for you to go to that area back and you can solve the questions very easily. So practice digital electronics. If you want to crack digital electronics section, you have to put very much effort, but you can actually study by practicing 2-3 questions. Okay, it's not that you need to always do same type of question, but practice 2-3-4 questions from one area of digital electronics. It is very easy for you to solve the rest of the questions. Okay, now anyway, let's do this. So we'll expand it. Z equal to, can use a different color. So Z equal to RSP. We'll start from this. Okay, RSP plus the next one is R S bar PQ plus R bar S P plus R bar S bar P plus R bar S bar Q bar. So this is your expression, which is actually consisting of how many terms? 1, 2, 3, 4 and 5. Now I'm going to simplify this using a K-map. Okay. Now here I'm going to use this same expression. Unlike the previous question which I have where I have introduced all the variables in all terms, No, I'm not going to do this here. I'm just taking a K-map. Okay. So I'm going to take a K-map here, which is a 4-variable K-map. Since it is having 4 variables, I'm going to simplify using this K-map. PQRS. I'm going to use a different color here. I'll be using green. Okay. So I'm going to, okay, sorry, it's red. 1, 2. Yeah, I'm going to simplify it to 3 and 4. Okay. 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0. Now I'm going to put these, that is, I'm going to put ones for all these terms. Wherever these terms are coming, for example, for this combination, what term is coming, there I'm going to put a 1. Okay. So for RSP, RSP means your R and S is 1. So this is R and S, and P is 1 here. So for these 2 columns, you have 1. Okay. So that's what I'm saying in the previous question also. You can simplify with the given expression rather than putting or introducing variables. But for more clarity, we have introduced the next variable. So here, if you are introducing the next variable, for example, Q, you have to put here Q plus Q bar. So you will be taking where Q is equal to 1 and Q is equal to Q bar, or Q is equal to 0. Okay. These are different ways of doing a same question, okay, or same thing. So 1 1 here, then next term. So we have put 1 here for this term. For this term, R specifically it is given, so you don't have to roam around. You can find it very easily. So R S bar, R is 1 here, and S bar, so it is here. Then P and Q, so it will be here only. Okay, so we have put a 1 there. Next one is R bar S. R bar S is here, and P. So P is 1 here. So it is there. Next one. So we have realized this term also. Next one, R bar S bar P. R bar S bar and P is here. Okay, so we have put for that also. Last term. Then R bar S bar and Q bar. So R bar S bar and Q bar is here also, and here we have already put a 1. So these are all the terms. Okay. Now I'm going to simplify this K-map. So in order to simplify, in the previous question we didn't want to simplify because we need to find where all these ones were present. But here we don't need the position of ones. We need the simplified expression for Z. So for that, we need to actually simplify this K-map. Okay, so I'm going to start simplifying by pairing. Okay, pairing of these ones and pairing of these ones. So we'll be pairing as multiples of 2. So here we can pair these 4 ones together. What is the expression coming? It is PQ. So I'm going to write the expression, final expression here. Is it equal to PQ plus, then here these 4 ones I'm going to pair, and then I'll be here, since there is a 1, I'm going to pair this with this one. Okay, so that's why I've kept it for this as separate, so that I could pair it with this. So here I paired and this with this, and these 4 ones I have paired. So what is the expression for these 4 ones? The common variable here, column wise it is S, row wise it is T. So it is a PS, P and S. That is the second term, or second term. Then the third one is for this pair. So the last pair is for R bar, S bar in column wise, and row wise this row and this row, which is the common element is Q bar. So the expression is Q bar, R bar, S bar. So this is the simplified expression for your output Z. Okay, so I hope you understood how to simplify it. So this was actually the same method which we adopted for the previous question also, but there was a little difference. One difference was we have introduced all terms in all variables in all terms, but here I have not done that, just to make you sure that you can also use this expression to simplify the K-map. And also there, we didn't wanted the expression, we only wanted the positions of the min terms. Okay, so that was a little bit easy. Here we need to pair and we need to find the final expression. Okay, so this is the final expression, PQ plus PS plus Q bar, R bar, S bar. Okay, so these are the 4 questions which I have included in this video. I really hope that you understood how to do the multiplexer questions. In the first 2 questions, I've tried to simplify little bit simple ones. Last 2 questions were a little bit difficult because K-map was also introduced. Okay, so I really hope that you found this video useful. Please do try to share this video maximum, and also if you found it useful, please do give it a thumbs up. And if you want more videos, please do subscribe to the channel. Thanks for watching and keep on watching.